All right, so we're going to start looking at hyperbolas. So I just kind of want to remind you what a hyperbola is. So I'm going to put a different picture up here. When we have this shape, a hyperbola is when we cut it where it would hit both, oops, the top part and the bottom part. So we're going to have two pieces in our graph. So I actually skipped ahead a little bit in the notes because I wanted to go through the examples together. Since you're going to have a formula sheet, we're skipping right to the examples. You can find the equations and templates in the key. So I want to point out some things in these pictures real quick. The dotted lines are your asymptotes. We need to have those asymptotes so we know how wide our curves are going to open, because we're going to be able to find our vertices. So this is one of them and this is the other one. And then the like floating dots would be your foci. So just like an ellipse, we have two foci. And then the dotted lines are our asymptotes, and we need to figure out where those are so we know how close to get our curve, or where our curve is going to go. So we can see the equations for them up here. Another thing I want to point out is this box really helps me graph a hyperbola, and then it's out A to the curve, and then this length here, ooh, my bad, is B. And I'll show you how we can utilize this box when we're graphing. For this one, since this is vertical, this would be my A, and then this would be my B. So we're going to go through a couple examples together. I want to first look at example 1. So I'm going to scoot this up a little bit here. We have our equation, and we're asked to find the vertices, the foci, and the asymptotes, and then also sketch it. So I'm going to label what I need in the middle, leave room on the left for work, leave room on the right for the sketch. So the first thing I notice is in my equation, it does not match a template that is on my formula sheet. Just like with an ellipse, it needs to be equal to 1. And so right now it's equal to 144. So the first thing I'm going to do is divide everything by 144, every single term. So I'm going to go ahead and simplify. If I want to simplify fractions, so this first one here is 9 divided by 144. In my calculator, I would type 9 divided by 144. I get a weird decimal, and then I'm going to hit my math button, which is under my alpha key. And then I want option 1, so I hit enter, and then I'm going to hit enter again. So it's going to take my previous answer, which was the decimal, and I'm converting it into a fraction, and I get 1/16. So it ends up being like 1x squared over 16, and I'm just going to write it as x squared over 16 because there's an invisible 1 in front of that. And then I can do that for the next one as well. So 16 divided by 144. When I convert that back into a fraction, I get 1/9. So I have x squared over 9 equals 1. So something that I want to point out with a hyperbola is that we have a minus sign here. In an ellipse, it was a plus. For a hyperbola, it is minus. So this is my equation. So I'm going to compare it with my formula sheet and see if it's going to be horizontal or vertical. Now, I don't care which one is larger. What I do care about is which one is positive. So if I have a minus sign, technically this fraction would be like negative. I care about the positive version. So since my x squared is listed first and that's positive, that means it's going to be horizontal on my x-axis. So I'm going to make a note here and know it is horizontal. And then if I want to quickly write the template so I have it since I don't have a formula sheet in front of me. This is the template for a horizontal hyperbola. So using this information, I can figure out a squared, which means I can figure out a. I can figure out b squared, so I can figure out b. So on the side here, that's the work that I'm going to do. So my a squared is the number that's underneath my x squared. So in ours, my a squared is 16, which means my a value is 4. My b squared is 9, which means when I take the square root, b would be 3. If I want to find c squared, I'm going to use my formula. This formula is different from the one for an ellipse. This one we're adding a squared and b squared. So I want to be careful with the equation that I'm using. Make sure you're using the one that's for the correct conic section. So this is the one specific to hyperbolas. So I can go ahead and plug things in. I don't have c squared, but I know a squared is 16 and b squared is 9. 16 plus 9 is 25. So I know c would be the square root of 25, which is 5. So with the information we just found out, I can go ahead and figure out characteristics for our hyperbola. Right now, I'm still going to identify the center. It is still at our origin. We haven't worked on moving them around. I do need to figure out what my vertices are because it asks for that. I need to figure out my foci. And I need to figure out my asymptotes. So my vertices, if I look at my formula sheet for a horizontal parabola, is based on my A, and it goes in the X spot. So my vertices are going to be plus or minus my A, which is 4, comma 0. My foci, again, since it's horizontal, my number goes in the X spot, and that's still based on my C. So I have plus or minus my C, which we said our C was 5. So plus or minus 5, comma 0. And then for my asymptotes, I'm going to write the template down here. So we have y equals plus or minus b over a x. So I'm going to plug in my b and my a, and then I'm going to write it back up here. So I have two of them. One's going to be positive, one's going to be negative, but I'm just going to write it like this. Since my b is 3, that goes on my numerator, and then my a was 4, so that goes in my denominator. So my two asymptotes would be y equals 3/4 x, and the other one is y equals negative 3/4 x. Those are my two equations for my asymptotes. So now when I sketch my graph, let's see, my A is 4. So I'm going to go about 5 tick marks in either direction, and how I figure that out is my A is 4, my B is 3, my C is 5. So I'm only going to go about 5 in either direction. All right, so I have my coordinate plane. I know my center is at the origin, so I'm actually going to start by graphing my vertices. So my vertices are at positive 4, comma 0. So this is one of them. I'll label it V2. And then the other one is negative 4, comma 0. So this is my other one. So one vertice, or both vertices there. Something else that I know is my foci, so I can go ahead and plot those. My foci is positive 5, comma 0 and negative 5, comma 0. So this is going to be F2. I like to put the same sub numbers for both of them. And this one is F1. So I got my two foci there. And then I have to graph my asymptotes so I know how wide to make each curve. So I'm sorry. A hyperbola looks like there's two parabolas together. So it's kind of weird because we have these tick marks. I'm going to start by graphing the positive. So when I graph this, my y-intercept is 0 because there's no b, and my slope is 3 over 4. So I'm going to rise 3 and I'm going to run 4. So starting here, I'm going to go up 3, then I'm going to go over 1, 2, 3, 4. So that's about it. I also don't really have a ruler. Do I have a ruler? So I'm going to use just like a pad of paper. So this is my pad of paper. That's my ruler. And I'm going to connect the point here through the origin with a dotted line since it is an asymptote. I'm going to go all the way through so I can see it through the whole graph. And then I would do the same thing for the negative version. So starting at my origin, my rise is -3, so I'm going to go down 3 and then run 4. I go down 3 over 4. I draw my asymptote. That's one way to do the asymptotes. I actually think there's an easier way, and so I want to show you that as well. Since I know my vertices are based on my A, I'm going to use a different color here. Hopefully those pen marks. This length is A, and then this length would be like -A, which means I want to go vertically B units, or like the amount of B. So if my B value is 3, starting at my origin, I'm going to go up 3. This would be my B, and I just want to label that. And then down 3. And what I'm doing here is I'm creating that box. So I'm going to scoot this a little bit here. Back in these images, we have these boxes here, and you'll notice the asymptotes go through the corners perfectly. So if we can make this box, we just connect the corners for our asymptotes, and that's going to be a lot easier for us. If you don't think this is easier, then don't do it this way. Go ahead and graph your equation here using slope-intercept form. But I'm going to do this in red. So I'm going to create a vertical line through my one of my vertices here, and then wherever I put my point for my B, which is technically my co-vertice, I'm going to make a dotted line kind of out there. Same thing here. I'm going to go down, and then this should be across here. Dun, dun, dun. So hopefully you can kind of see what I'm doing. So I created that rectangle. It is B away from the center and then A away from the center. And you'll notice that first asymptote we did went through the corner, went through this corner. I do have to draw in my other asymptote, so I'll do that right now. A ruler would have been better, but I don't have one. So we're going to say this is our other asymptote, and I don't want to cut off any letters. And you can see it goes through the corners perfectly for both of them. And then that's going to tell me how wide to make it. So my graph always goes through my vertice, never my focus. So coming from the vertex, actually, I'll do a different color so it stands out. We're going to come here. We're going to get really, really close to our asymptote on both sides. Same thing here from our other vertice. Oop, that one kind of got a little close. And then that's I cannot say the word, my hyperbola, and I'm done. So there's a little bit extra work since we have to make the boxes, or we have to graph the asymptotes, however you want to graph them, and then we have our hyperbola. So we're going to do another one. I'm going to go through the other one faster, so feel free to pause the video along the way. But we're going to try this one. So looking at my equation, it is not equal to 1 right now. And actually, I have to move this 9. So I'm going to move 9. And then I have x squared minus 9y squared equals negative 9. I want it to be equal to a positive 1. So I'm going to divide everything by negative 9. So what I have left is negative x squared over 9. Well, negative 9 divided by negative 9 would be a positive 1y squared, which is technically over 1. So since I didn't have a fraction, I'm going to make it a fraction. So that helps me. And then this turns into a positive 1 as well. Now you might be thinking, well, there's a plus in the middle, but this is not an ellipse, because if I rearrange this and put my y squared over 1 first, and then I have this negative x squared over 9, that would be subtraction. So let's go ahead and rearrange it. I'm going to switch these around. So this fraction is going to go out in front. My positive version is always in front, and then I'm subtracting my other fraction. So that is the equation that we're going to use to graph the hyperbola. So now that it's rearranged here, I know that my y squared is positive, so that tells me this is going to be vertical. It's going to open on the y-axis because my y squared is positive. And then I can go ahead and figure out my a squared and my b squared. So my a squared is always under the positive 1, so my a squared is 1, which means my a is also 1 because the square root of 1 is 1. My b squared is 9, so my b is 3. And then using my equation, I can try to find my c value. So I have c squared equals, well, a squared is 1 and b squared is 9. So that is 10 when I add them together, which means c is the square root of 10, which I need to figure out what the decimal version of that is. Approximately 3.2-ish, 3.16 something. So rounded to 3.2. So we found everything that we're going to need. My center is still at the origin, but I'm going to start by identifying my vertices, my foci, and my asymptotes. So my vertices are still based on whatever my A is, but since it is vertical, the number goes in the y spot, so it's going to be 0 plus or minus 1. My foci is based on my C. The number still goes in the y spot since it's a vertical hyperbola. And I'm going to use the decimal because to me that's going to be a little bit easier to graph. So 0, comma, plus or minus 3.2-ish. And then our asymptotes for this one, I'm going to write the template again. Because it's vertical, now it is A over B times X. So when I do this, I have Y equals plus or minus, A value is 1, my B value is 3. So I have plus or minus 1/3 X. So I realized I didn't leave myself a lot of room, but that's okay. So looking at my A, B, and C, they only go to like 3. So I'm going to do a coordinate plane where I go to 3 in all directions and hope that it ends up working out. So I'm going to go 1, 2, 3. So I know it's going to be vertical, which means if we look at the example up here, instead of it being on the left and the right, it's going to be on the top and on the bottom. So I have that kind of in my head. I'm going to start by graphing my vertices. So 0, positive 1 is here, and then 0, negative 1 is here. My foci, 0, 3.2, I'm going to put right above 3. So this would be one foci. That would be my other foci. And then I do need to make my box, or I need to graph my asymptotes. Whatever you are comfortable with. So if you just want to graph it like this, our y-intercept is still 0. I'm going to go up 1 and then right 3. So up 1, right 3, put a dot, connect those. And then I do the negative version. So I go down 1, right 3, make a dot, connect those. You have your two asymptotes. I'm going to make the box because it will end up being easier when we shift our hyperbolas. So I know that this right here was my A. So that means my B has to go left and right. So I'm going to go out 3 because my B value is 3. And then I can make this rectangle. It's a little long and skinny, but that makes sense for my A and my B value. Not the greatest, but that's okay. So I have a corner here, I have a corner here, and then those places. So I'm going to draw in my asymptotes, and then I'll be able to finish my graph. So I have my dotted lines for my asymptote, and then another dotted line for my other one. Make sure it's going through the corners of my box there. All right. And then I just have to graph the actual hyperbola, so the curves. So with my vertex, I'm going to go as close to the asymptote as I can. So this is going to be a very wide hyperbola. And then same thing on the bottom. I get close to those. Ooh, that was a little close. That's okay. It's a sketch. And that is my hyperbola. All right, so we're going to flip to the back. And we're going to look at the back two here. So these are a little different because for these, I don't have the equation, but I do have some characteristics. And then using those characteristics, I will be able to sketch the graph. So for example 3, it says find the equation of the hyperbola with vertices at plus or minus 3, 0 and foci at plus or minus 4, 0, and then sketch it. So the first thing I want to figure out is if it's vertical or horizontal. So looking at my vertices and my foci, the numbers are in the X spot, and so I know that it is going to be horizontal because it's going to open on my X axis. So it's going to look something like this. Ooh, that's really close to the top there. So over here, I'm going to say horizontal. If you want to make note why, it's because the numbers are in the X spot. Numbers in the X spot. So I know that A is 3 because my vertices are based on A. And then my C value is 4 because my foci is based on my C value. And then I can find B. So that's what I want to do next. So using the same equation, I have C squared equals A squared plus B squared. Well, C was 4, so I have 4 squared equals, my A was 3, and then I have B squared, which I don't know yet. 4 squared is 16, 3 squared is 9, and then I can go ahead and solve for B squared. When I subtract from both sides, I get 7 equals B squared, so that means B equals the square root of 7. So right now I have enough to write my equation. Since this is a horizontal, I know my x squared is going to be first because it's positive. So x squared over a squared minus y squared over b squared equals 1. Since I know my a and I know my b, I can figure out what my denominators would be. So a was 3. Well, 3 squared is 9. And then I have y squared over b squared. Well, here b squared was 7, so this denominator is 7. So this is my equation. And now I can go ahead and sketch my graph. So I have my coordinate plane. And I look at my A, B, and C, 3, 4. So I'm going to go about 4-ish in every direction. I'm going to start by graphing the information that I was given. So my vertices are here and here. And then my foci are pretty close to it. And then I can make my box. So for this one, I'm going to use a different color here. So this was A, which means I'm going to go B up and B down. And this actually helps a little bit more because if my B is a square root of 7, that's going to be really hard to do slope if I have to rise like a decimal amount. So I need to figure out what the square root of 7 is. Square root of 7 is about 2.65. So from my center here, I am going to go up 2.65. So I'm going to put it just above 2.5. And then down 2.65. So a little bit further than 2.5. And I can create that box. So I'm going to go through my vertices. And then through those points to create my rectangle. Now I just have to make sure that it goes through the corner, and then corners on this side. So again, I'm using my pad of paper, and I'm going to draw my asymptotes. So there is one of them, and then I'm just going to scoot this down a little bit while I do the other one, and then I'll put it back. Whoa, there we go. So now I can go ahead and finish. I always go through my vertices, not my foci. So through my vertices, close to my asymptote, close to my other asymptote. Oh no, I literally did what I just said not to do. Don't go through your foci. Through the vertice. Disregard that. I don't have white out. So that should not be there. And I have my hyperbola. All right, example 4. This is the last one, but I still want to go through it in case someone wants to watch it maybe later on. So again, I don't have an equation. I want to figure out what information I do have, and then I can go ahead and start. So my vertices, my number's in the y spot, so I know that it's vertical. It's going to open up on the y-axis. I also can always look at my equation sheet and see if horizontal or vertical writes their vertices like this. So you don't have to remember if it's in the y spot, just utilize your formula sheet. I also know that if my vertices are at 0, 2, and 0, -2, that my A value is 2. The other piece of information I have is my asymptote. For a vertical hyperbola, my template for an asymptote is A over B. So you might be able to figure out what B is right away, but if it was ever something weird, what I'm going to do is I'm going to take this 2 and I'm going to set it equal to A over B. So I have 2 equals A over B. Well, if I know A is 2, I have 2 equals 2 over B. Technically, I could cross multiply and solve it, but B has to be 1 because 2 divided by 1 is equal to 2. So b is 1. If you want to see me cross multiply, what I would do is, since this is a whole number, I put it over 1, and then I multiply 2 times 1, and then 2 times b. Well, 2 times 1 is 2, and then 2 times b is 2b. I divide both sides by 2, and I get b equals 1. So over here, I'm going to say b is 1. And then I can go ahead and solve for c. So I have c squared equals a squared plus b squared. So I plug in my a and my b, and then I can square them. So I have 4 plus 1. So c squared is equal to 5, which means c is the square root of 5, which is approximately 2.24, 2.2-ish. So for my equation for a vertical hyperbola, my template looks like this. I have y squared over a squared minus x squared over b squared equals 1. And then I can plug in what I know. So I always leave x and y in my equation. Well, a squared is 4 because a was 2. 2 squared is 4. B squared is 1 because 1 squared is still 1. So I can leave it like this, or if you just want to write it as x squared, since x squared over 1 is still x squared, either is fine. I'll include both here, whatever you are comfortable with. I just don't think that this looks like a hyperbola for the second one, but whatever you prefer. So then for my graph, I'm going to sketch one down here. I'm going to go about 3 in either direction, and I'm spacing them out a little bit more since I have the room. Whoa, those are not even. So I'm going to start with my vertices and my foci. So my vertices are at 0, 2. So 1 there, and then 0, negative 2. There's my second one. Oh no, you can't see that. My foci, if I were to write them down, so I'll write them down here real quick. My foci are going to be 0, comma, plus or minus whatever my c is, which is about 2.24. And it goes in the y spot because it matches the vertices. So 0, 2.24 is pretty close to this one. I'm going to say this is F1, and then negative 2.24 is about here. For my asymptotes, if this is my A, because that's my A always goes to where my vertices are, that means B has to be horizontal. So B would be 1, and this would be the length of B. So I can go ahead and connect that box. So through B, and then through my vertices. And I have my little rectangle. So now I can draw in my asymptotes, and then I'll be able to graph my curves. So corner, corner. Oh no, that's a little off, isn't it? Whoa, that was really off. I didn't do a good job putting it through the corners. So I make mistakes too, it's okay. So now I get to graph them. So through the vertice, close to the asymptote, through the vertice, close to the asymptote. And I have my hyperbola, and we did it!